So allow me to speak for 2 minutes in Greek and then... Καλησπέρα σε όλους. Ήμασταν λίγο συγγνώμη για τη μικρή καθυστέρηση. Απλά προσπαθούσαμε να συνεννοηθούμε λίγο πώς θα γίνει η παρουσίαση. Βλέπω αρκετό κόσμο και σήμερα, παρότι κάνει ζέστη, αρκετή. Όπως είπαμε λοιπόν, όπως ξέρετε ήδη, το θέμα είναι τι ακριβώς είναι αυτό που έχω στα χέρια μου. Φαίνεται λίγο περίεργο, αλλά υπάρχουν οι κατάλληλοι άνθρωποι να σας εξηγήσουν τι ακριβώς είναι. Θα μιλήσουμε λοιπόν για κατασκευαστικές λύσεις θερμογεφυρών στην ελληνική οικοδομή. Κυρίως θα προσπαθήσουμε θα προλάβω 2 βασικές σας ερωτήσεις, που είναι πώς λύνουμε το πρόβλημα μπαλκόνι και πώς λύνουμε το πρόβλημα πιλωτή, διότι αυτό είναι βασικά το μεγαλύτερο μέρος της θερμογέφυρας στην Ελλάδα, αλλά και όλες τις άλλες λύσεις που μπορούν να υπάρξουν. Προφανώς και θα βάλετε θέματα όπως θέλετε. Οι άνθρωποι που συμμετέχουν είναι τα βασικά στελέχη της εταιρείας SCHOECK, η κυρία Καρόν, ο κύριος Καρέιρο και ο Μπενουά, ο οποίος θα μας κάνει τη βασική εισήγηση και τη βασική παρουσίαση. I'm giving the floor direct to Benoit. I forgot to tell you guys that we have a hot day in Greece, in Athens today. We are over 37, 38 degrees.
Oh, you're a lucky man. It's quite cold where we are.
Not lucky.
We are like 16. It's been raining for 2 days.
I know that it's raining, but okay. In order to tell you that our beaches are still empty, you can come if you want, but be careful also.
Anytime.
So, Benoit, you can share your screen and you have the floor.
Yeah, so I'm going to start.
Just one word, if there's something which
Isabel
is not clear or something you don't understand, just raise your hand. And
Yes.
We'll gather all the questions for a discussion at the end. I don't know if
I will also follow the chat, because some people, they don't have some people, they don't have the microphone and so on, so they make questions on the chat, but okay, I will do it.
Okay, so I'm going to share my screen. Isabel, can you confirm that you can see my slides?
No, we can see a beautiful picture with deux de chevaux.
This is, you have to know that that Benoit is French.
Okay.
Yeah, why?
I see it.
So,
I believe you also French, or not?
Me, yes, I am too. And Jonathan, the head of our department, is from Canada.
Okay. So, Benoit, do you need any kind of help or what? He's coming
probably
back.
To share the screen, maybe? Is he a host?
I don't know. He came back. Just give me one. He is co-host, yes.
But anyway, thank you everybody for taking your time after work. I guess it's after work for you as well, to get to learn about solutions against thermal breach.
Benoit, are you there?
Yeah, I'm back, but I can't share my screen. You should activate the screen sharing for me.
Okay, just a moment. There you are.
And now you should be able to see my screen.
Yeah.
Yes, perfect.
Yeah. In full screen? Is it in full screen?
Yes, it is.
Yeah. Okay, great.
Let's go.
So let's go. So now you're supposed to see a picture of the isocolumn. I'm right?
Yes.
Okay, great. So let's start with a small picture of us, which is obviously nicer than the reality. For me, at least for me. Just just feel free to save our contact data if you want to get in touch later or for any question. Okay, so I'm going to speak very quickly about the company itself because it's not the main point here anyway. So I just wanted to say that the company has been created like 70 years ago, sorry. And as you can see, we've been developing new products and improve existing products. Today we have, I would say, basically three different kind of products. The thermal bridges products, which is why we are there together this evening, the impact sound insulation products, and the reinforcement products. We do not just offer products, we have also, let's say, a wide range of services. We can provide the beam files for our products. We also offer software for the design. So this is not really for you guys, this software, it's more for the engineers, but anyway, it's interesting to know that it exists. And something for you, I guess, the detail center, it's on our website, and you will be able to look for details, like, hey, how or where the window should be, or how I can achieve the waterproofing on the balcony, and so on. So you will find a lot of information on that. So this is where the company is active. Of course, we have countries where we have subsidiaries and we are more active, and then we have some other countries where we don't have any subsidiaries, and our department, so the emerging market department, is responsible for. Okay, so this was again a very quick introduction to the company, just so that you know who we are. Now we are going to talk about the thermal bridges. So as you maybe know, the balconies are very efficient to dissipate heat because of their shape. It's because they are quite similar to cooling fin. You know, cooling fin. I don't know if you can see my mouse. No.
No.
No. Okay. So too bad. I wanted to point the picture. Anyway, the cooling fin. It's they are those small parts on the engine you can see, and the goal of that is to increase the exchange surface between inside and outside, which is great in the case of an engine and not that great in the case of a balcony. But anyway, the similarity is quite striking. And this is what I would say you want to avoid for a balcony. So why do a thermal bridge occur? It's basically due to the difference of thermal conductivity between materials. So here I show some examples of the thermal conductivity. So this is the value you see. The bigger the value is, the worse it is, because the more heat will go through this material. Just as a comparison, the concrete is around 1. So when you use a thermal break, instead of having a lot of concrete with this value 1 and reinforcement steel with this value between 36 and 54, you replace that with a lot of neopore with a value very close to 0 and a few steel, obviously stainless steel. We are going to see that a bit later, with a value between 12 and 45. Yeah, why does it become important to pay attention to the thermal bridges? Because, well, as you know, back in the time, in the old buildings, you don't really have this kind of issue. You know, in a building, the heat will take the route with the smallest resistance. So the route with the biggest thermal conductivity. So for the same balcony, if you increase the thickness of the wall insulation, you will increase the thermal bridge. So in other words, in a modern and better insulated building, the thermal bridges will be worse than in the same building, but with less insulation. So just a second. Yeah. Here you can see a couple of examples where you can find some thermal bridges. They are not the only one, but let's say the most common thermal bridges. So you have, of course, the balconies, but also some other connections like the parapets, or the connection with the basement, or the connectors in sandwich panels. But we are going to talk about balconies this evening, but just keep in mind that there are other cases. So why are the thermal bridges an issue? I would say there's nothing you can't deal with, because you can always find a way to fix that. About all the issues which are listed there, it's always more expensive afterwards, and then comes the real question: who is going to pay? And the answer is usually the designer, so the architect, the engineer, etc. And also, let's keep in mind that this kind of issue, they are based on the condensation and mold growth. Again, back in the time in old buildings, it was not really an issue because the thermal bridges were not really an issue, because what I said a couple of minutes ago. And on top of that, buildings were not airtight. So, I mean, there were a lot of small holes or so in the building envelope, and they were pretty well ventilated. Now we try to avoid the building to be over ventilated, so we usually build airtight building, and we pay a lot of attention on that. And the drawback of that is that if the risk of condensation and mold growth increases. So yeah, again, in modern buildings, it becomes a more important issue than before. Okay. Now, just a couple of words about the thermal flows. So this is a picture which describes the thermal flows in two different situations. So it depends if you are in winter or in summer. So those are the main thermal flows. Of course, you could add, I don't know, the internal loads, like the computers or people cooking in the building and so on. But the main ones are those ones. And the thermal bridges can go up to 20 or 25% of the whole thermal flow. So when you have a lot of balconies, it can be a large part of your energy losses in the building. And this is why it's important to pay attention to that. The role of a thermal break is to insulate and to support the elements. So with elements, here the example is a balcony. So that means you don't need any extra insulation around the balcony, and you don't need any extra structural support like a column or so, because the thermal break will do both. And this is what is great with this kind of product. So on this picture, you can see the distribution of temperature within the slab. So the red is hot, the blue is cold. And as you can see, the thermal break, let's say, keeps the heat on one side and the cold on the other side. So I just want to show you guys a couple of values from a third-party report, which has been made by a company, I guess it was in Canada. So they calculated several values. And of course, the value of a thermal bridge depends on the construction, the thicknesses of the slab, the insulation, and a lot of things. There are just a couple of examples. But anyway, just keep in mind the order of magnitude is similar for other cases. So we are going to compare what they call conventional construction, so just the balcony, the concrete going through, and then a construction with a thermal break. Note that it's a thermal break with steel rebar, so quite good, but we offer even better products. Okay, the values. So if you see the first line, so this is the conventional construction, and you can improve it a little bit by insulating the curb. So the curb is, so, well, if you don't see my mouse, it will be tough to explain. It's the blue part above the step between the balcony and the internal slab. Anyway, you can improve a little bit that by adding some insulation, but using a thermal break, you can reduce dramatically the energy flow going through the connection. So again, remember here, no matter if we are talking about heating or cooling, this is the flow going through the balcony. So that means basically the money flowing through the balcony. And as you can see with the thermal break, you can decrease the thermal flow by 5 or 10. So it's huge. And of course, it would be still better if we use the product with fiberglass. We are going to talk a bit later. Talking about condensation. So this is the comparison of the surface temperature in the corner. So in the corner, it's where you see the T1. So you can see so of course, it's the Canadian case. So cold outside, hot inside, but it's the same principle everywhere in the world, even if you are in the summertime. So as you can see, the common case, you have -1. So obviously you will have a lot of condensation in this corner. You can improve that a little bit by insulating the curb, and you can reach 4 degrees. Spoiler alert, you won't avoid condensation with that. And if you use a thermal break, then you can reach a very interesting temperature like 17 or 18, and then you will avoid the risk of condensation in this corner. And of course, you will avoid all the issues we've listed above. So this was an example for a concrete balcony attached on the concrete slab. There are thermal breaks for almost every kind of connection. So concrete to concrete, concrete to steel. So concrete to steel, it's typically when you have a sunshade or a steel canopy attached on the concrete slab. Or we also have steel to steel products. So when you have a steam penetrating the building envelope. So just a couple of pictures so that you can see how it looks like. Well, obviously, this is a computer picture. In reality, you won't be able to see the product because the product is hidden in the slab. But just so that you understand where it's installed. So here you can see the balcony with the concrete to concrete isocore below the window. Of course, there's not only the balconies, there are a lot of other connections. Here we have the example for parapets. This is the product for concrete to steel connections. So here you can see that the balcony is a steel balcony. This is the same kind of product, but for renovation purposes. So it's when you renovate a building and you want to add a new balcony, so we have a solution for that. Steel-to-steel connections. So you can see that the thermal break is at the corner, at the top right. I'm sorry that I cannot show my mouse. So just an example, it's a detail. How it, again, it's just an example. It doesn't mean it has to be done like that. Just an example from our detail center, but there are a lot of them. Yeah, it just shows how it can be attached with the window, the waterproofing, the cladding, and so on. We also have some solutions for special cases. So when you have a step between the internal slab and the external slab, we have, in fact, way more possibilities. It just, I cannot show everything, and it's anyway not the point of this presentation today. Just if you have any question for any project and you're not sure how you can deal with a thermal bridge for a project, just get in touch with us. I mean, even if you are very soon in the design, we can discuss and provide you a solution. Here we have the example of a parapet case. So far I know it's not a big issue for you, but I just want to use that to help making my point regarding the balconies. So as you can see here, we compare solution without thermal breaks and with thermal breaks, and the other solution is packing the parapet. So it avoids the thermal bridge, but it's quite expensive. This is the first point, and it also creates some other issues, especially if you have a deck on this roof, because of the extra thickness of insulation. So you reduce the area of the surface of the deck. You have a cladding on the internal side, which can be damaged. You don't have any rendering, so because you need to protect the insulation, and you have all the waterproofing details there. And in fact, it's the same with balconies. You could pack the balcony to avoid the thermal bridge, but again, it will be a nightmare for the details like waterproofing and all those details, and you will anyway end up with like a 40 or 50 centimeters thick balconies, and the architect will love. No, I'm kidding. He will hate you. Yeah. So seriously, yeah, using a thermal break also helps to keep those details, let's say, nice and easy to realize. To build. Sorry. So I'm just going to describe a little bit our concrete-to-concrete product. So I told that the thermal break insulates and supports the balcony. So you will find some elements in the thermal breaks which insulates and some other which support the loads and so on. So starting with the structural elements. So you have some steel bars going through the insulation. I'm sorry, I cannot show with the mouse. But we have different kind of steel. We have the black steel, and so the black steel is on the left and on the right of the product, and we have some stainless steel going through the isocord, through the thermal break. The reason for that is that the stainless steel is more durable, of course, so there's no risk of having that being corroded by water over the years and the years. And the second reason for that is the thermal conductivity of the stainless steel is way better than steel. Just note that the straight bars can also be glass fiber bars, because the thermal conductivity is still better than stainless steel. And at the bottom, the blue and gray thing you can see at the bottom are the compression elements. So all those elements are there to support the forces coming from the balcony. And then you have the insulation body of the thermal break. So this is, let's say, in the middle, and on the top and at the bottom you have some fireboards protecting the insulation and the steel and all those elements. So just in case there's a fire below the balcony, and so to make sure that the balcony remains and can support the loads. Okay, talking a little bit about how does it work. So I'm not going to go through all the math and everything, but just keep in mind that the forces are supported by the bars. So you have some bars in tension, the bar at the top and the inclined bar are in tension, and the element at the bottom is in compression. And with those three elements, we are able to support the forces from the balcony and bring those forces on the edge of the internal slab. So very briefly, which forces do you need to consider? So does the engineer need to consider for designing the thermal break? So of course, the weight of the balcony, the live loads. So with the live loads, we mean the people on the balcony and everything which could be on the balcony, but also the wind loads, earthquakes, and thermal expansions. So for thermal expansion, this is something which is let's say automatically included in the values, in the resistance values we give. So this is not even a question. I think for you guys, it's important to say something about earthquake. So there is in the Eurocode, so the Eurocode is the structural building code which is applied everywhere in Europe and even in some other countries. And there's a chapter in the Eurocode 8, which is the code for earthquake, which explains how to calculate the forces, the seismic forces applied on the balcony. It's a very easy calculation. In fact, it's something you can do within a couple of minutes. Then you apply those forces on the balcony and you just design the thermal break so that it can support those forces. So this is something very, very easy. There is, in fact, a similar way to calculate to design the thermal break for seismic forces in the North American codes. So in Canada and in the US, it's very similar. It works very well. It's also pretty much the same in Japan. So we have an approval in Japan, which is obviously a very seismic area in the world, maybe the most one, the biggest one. And this is pretty much the same calculation as in the Eurocode. So again, this is something that the engineer can do when he does the design of the thermal break, but usually at SCHOECK we provide you the design of the thermal break. So this is a calculation we are going to do by ourselves. We just need a couple of informations like the ground accelerations and so on, but this is some information which is usually provided by the structural engineers, and this is something very easy to do. So our products are rated by several independent labs. So they are rated REI 120 or 90. So that means they can keep their resistance, integrity, and insulation for 120 or 90 minutes. Just a couple of pictures of a fire test. So this is a fire test which lasted 90 minutes in this case. So you can imagine that you have the slab resting on 2 supports. On each support you have some thermal breaks, and as you can see, the concrete has been really damaged, but the thermal breaks are still holding the slab. And if you see the curve on the right, you realize that the temperature in the testing facility has reached over 1,000 degrees, and it lasts. So yeah, this was a test for rating. Again, it's been made in some official facilities. Very briefly, just wanted to say that we have at SCHOECK, we are very lucky because we have large testing facilities. So we use them for our quality control, because our quality control plan is very strict. It requires to test like each welding, each bars. I mean, this keeps busy several people full time, definitely. But this testing facility also allows us to make R&D tests in our own lab. It's a certified lab, and we are very proud of that. But it makes us able to quickly test and develop new things or improve products very quickly. Regarding the approvals and certificates, so we have some approvals and certificates in, we can say, a lot of countries. So in North America, of course, in Europe, we have an ETA, but we have also some national approvals in UK, France, Germany, and so on. We have an approval in Russia, and we have some approvals in Asia, and as I told you, in Japan. And of course, the company is certified in several ISO norms. So this is very important for you. We have some a lot of products which are certified by the Passive House Institute. So this is just an example. This is for our cantilever products with fiberglass. But you can go on the website of the Passive House Institute. We have like 15 or 20 different products rated by the institute. Or you can just ask us, and we will be more than happy to provide you the certificates. So this is just an example on how it looks like in the factory or in the construction site. So here we have a picture. So this balcony is being precast in the factory. So you can see that the bars are white because this is the product with the fiberglass. So bars are made from fiberglass. This is why they are white. And then on the right side, you can see the balconies ready to be shipped to the construction site. And on the left side, you can see a precast balcony on the site. On the right side, so this is a cast-in-place balcony, again with the fiberglass bars. You can see them, they are white. Some other pictures. So here we also have some cast-in-place balconies. This is a corner balcony that you can see on the left. Those products are with, yeah.
Benoit, may I interrupt you, because we have exactly a question
Sure.
which fits in this picture on the right. A colleague is asking, how do you achieve connection when there is usually a beam supporting the balcony? As you see here on the right, there is a beam under the balcony. So where do you put exactly the isocorp in order to create the connection?
So with beam, you mean the kind of
horizontal,
columns
the horizontal one, the horizontal concrete beam.
Above the window, you mean?
Yes, exactly, above the window.
So well, as you can see, the isocorb is just
is in front of this.
Yeah, it's in front of the beam. I mean, the bars of the isocorb are going through the beam,
Okay.
and they are anchored in the beam or in the slab behind.
So the isocorb has exactly the same, let's say, width or height as the slab.
Yes, exactly. Let me just go back a couple of slides. I can show you a section of that. Yeah, here, for instance, you can see. So this is an example with a step. Or no, just a second. Yeah, maybe here it's better. Yeah, it's better. It's a better example. Here you can see that the isocorb has the same thickness of the slab. There's kind of a curb on the balcony, but the thickness of the balcony is the same as for the isocorb.
Yeah, but in this example, sorry for the interruption, there is no beam.
There is no
If it
beam.
were-
Yes, this is which is something which is normal in Greece to have beams also under the slab.
If there were a beam, where would that be? To the right or to the left of this application?
So in this case, the beam would be on the right of the isocorb.
Okay.
Let me just a second. I'm going to draw the beam. Yeah, but now I guess you can see the slide again. Yeah, so the beam would be there.
Mm-hmm.
Okay,
So
thank you.
the isocorb is coming, let's say, in front of the beam.
Yep.
Okay, but this is because I see also now the window has to be on top of the thermal break, or it can be also somewhere else, because this is a chain now that we have to to follow as somehow. I
Sure.
see in all
So
of your pictures the window installed exactly on top of the isocorb, but this in our case it cannot happen, let's say.
so the ideal case is that the window is exactly aligned with the isocorb. But you can have for instance, in this case, you could have the window on the right or on the left. It just, if you do that, it's a bit a pity, because you may have kind of a small thermal bridge.
Yes, okay.
You know, just imagine you would have your window, let's say 10 centimeters on the right. It would create kind of small thermal bridge. But
okay, you can also have another part of let's say something like hard polystyrol or something like that in order to minimize the thermal bridge again. But
yeah,
okay, the ideal case is to be on top of the isocorb. Okay.
Exactly, but I know it's not always the case, because there are other challenges when you need to attach a window. So again, this is the ideal case, but you can do something else. So I'm going back on my picture. Does it answer the question?
I believe so, yes. I don't know. There is also one, sorry, but if that beam is perpendicular to isocorb. Hey, I see here it is this case, exactly this case in this picture on the right. But I see the isocorb is in front of the beam, and it has the thickness of only of the slab. It doesn't have to do anything with the beam.
Yeah, because on this picture, just imagine that there will be some insulation glued on the wall on the side of the beam. So
Jonathan says there is a special isocorp to break the beam as well.
Well, when you have a beam penetrating the building envelope, so just imagine you would have a beam going from the left to the right.
Okay.
So perpendicular to the isocorp. So in this case, we have some isocorps for the beam.
Okay.
But
a beam supporting the balcony, you mean? Okay.
Yeah. For instance, yeah. But in the case, in this picture, you don't need any thermal break for the beam because the beam is inside. The beam doesn't go through the insulation. So the beam itself is not a thermal bridge.
Okay. No. The beam is not a thermal bridge. The slab is the thermal bridge here, for sure.
Exactly. But when the beam is the thermal bridge, then we have a special product for that.
Yes.
A product which is the same. I mean, you have some bars and it supports the forces. It's just the size of the product fits the size of the beam. But yeah, again, this is a construction site, so you can see the isocorp. But when the building will be completed, you won't be able to see anything because you will have some insulation, cladding, or rendering, or anything, and the isocorp will be hidden behind that. Okay. So I have some examples. So I have thousands of them, but I'm not going to show them, all of them, of course. So this is a project in BC, so on the west coast of Canada, which is obviously a highly seismic area. And we have balconies and balconies with isocorp up to the penthouse on the last floor. This is another example that you can see. So this is an example in Canada. So you don't have any concrete walls. So this is why you cannot see concrete walls. But I mean, the principle is the same because you have the isocorp between the balcony and the internal slab. So we have a project. This was a project in Africa, in Russia, in Korea, and that's it. I'm not going to show all of them because yeah, we don't have so much time. I wanted to talk a little bit about steel-to-steel connections. So steel-to-steel connections are achieved through this kind of thermal breaks. So the principle is the same as for concrete-to-concrete connections. We minimize the area of materials and we optimize the thermal conductivity of them. And this is how it looks like. So on the left and on the middle, you can see a very large beam, and you can see the modules on the top and at the bottom. And on the right, you have a smaller beam with only 3 modules, sorry. So again, when the building is completed, you cannot see anything. So this is a very special project we made in Antarctica. It's a scientific station for Brasilia. And the isocorp are in the red circle behind this cladding. Of course, you cannot see anything again.
Benoit, I think, now we see it. Okay, because we haven't seen this. Now we see your picture.
I'm sorry. So I'm just repeating. So the isocorp are in the red circle.
Okay.
So they are between the, let's say, the legs of the building and the building, and it has this very special shape because again, it's been made in Antarctica. So they built everything on, I do not remember in which country anyway, and they brought that by boats. And so this is why it has this very special design. So can you see the next picture now?
Not yet, but
not
I
yet.
hope it will come.
Okay. This is a project in Texas, so it's a museum.
We still see the old picture. No. Yes, we still see the old picture.
Okay, I'm sorry. Just
now we see the next one. Okay.
Okay, good. So yeah, it's a museum in Texas, so it's more hot climate for this one. And the next project, so maybe it will take a couple of seconds to show it. It's an art museum in France. It's a very fancy structure. You will see that. Hopefully.
Not yet.
It's my last slide anyway. So.
Okay, it's not a problem. It will come. I don't know why, but
no, it's funny. Why it suddenly becomes so slow. Anyway, yeah, I just wanted to point out that we can achieve a lot of different designs and shapes and everything. So there's a big flexibility when using this kind of products.
Now we see the museum.
Okay. And yeah, so that's it. That was my last slide.
Okay. Jonathan, do you want to show something? Because I see that you just uploaded a picture or something. Or what is this?
Yeah, I was just trying to upload a picture to the chat because it seems like there was still some questions about the beam. So
yes, because this is a normal static situation in our concrete skeleton in Greece. So beam is always there. Not always. There are also cases with Selner slabs where we don't have beams, but the normal situation is the beam.
Yeah, there's some other countries that are like that. Like I know in China, that's a very common example to support a balcony with a beam, and then in between the beams they can put insulation. So they don't actually have a slab connection, just beam connections. And yeah, we do have thermal breaks for that, as we mentioned. It's not the norm for here in Germany, but it is something we can do.
Okay. Do you want to share the picture that you wanted to show? I don't know. Because I saw something in the chat.
It's not a very nice picture, but can you see it in the chat or no?
I can, Jonathan, I can share my screen and show that. Maybe.
Okay, Benoit will show this one.
Okay.
Yeah.
So, guys, any other question? If someone wants to make a question, please raise your hand or take the microphone directly. Okay, we are close to 60 people now, but you can still ask if you want.
So, can you see the website?
Yes.
Okay. So this is the kind of isocolb we will be using for beam. So as you can see, it has the shape of the beam. So it's usually higher than wide. But the principle is the same. So you will have some bars going through the insulation body, and some fireboards to protect that.
Okay, fine. Let me make one first question, because I understand that many people, okay, they don't know where to start sometimes. Is it, if I understand well, maybe it is a stupid question, but I will do it. I understand that this product is a fully customized product. I don't have, or do I have standard dimensions for that? You have, or I say to you, this is my slab, this is my steel structure. Please send me 6 meters of that. And give me. How do you proceed with creating of a project, let's say?
Yeah, so it's not a stupid question. It's a very interesting question, in fact. So how does it work? So usually the project engineer, so the structural engineer, gets in touch with us when he has to design that, and we get the information from him. So we get usually the loads from the balcony. in case of project in a seismic area, so it's obviously the case in Greece, we need some basic information like the ground acceleration or the type of soil and anything, or this kind of information. But this is something the engineer knows because he needs those values for a lot of other things in his design. And when we get that, then we can make the study, so we make the calculation, and we tell to you, okay, you will need 5 pieces of this reference, 2 pieces of this reference, 3 pieces of this one, and so on and so on. And then when it's been ordered, we make a layout drawing for the construction company, so that the construction company knows where does go which element.
Okay, but the element is something which is on the list, or do you create every time in every project new dimensions, let's say?
So both. We do both. We have standard elements which fit in, I don't know, maybe
meaning standard here we have a fixed width and we have a fixed height also, or we had several heights and widths in a table, let's say.
So for the balcony products, they are usually one meter wide.
1 meter wide, okay.
Of course, you can cut them. If you have a balcony, let's say 3 meters and 80 centimeters, that means 4 pieces, and the last piece will be cut on the side. It's very easy to cut. I mean, you can take a handsaw, and within, I don't know, 10 or 20 seconds, it's done.
Okay. This dimension here, the width here?
Yeah. So this is for the width. So it's usually 1 meter, and you can cut it.
This width you mean now? This dimension is 1 meter or not?
The length.
Oh yeah. I'm sorry. I'm showing something else now on the. Yeah. Okay. It's confusing. I understand. It's confusing. I'm sorry.
Okay.
So this is the product for the balcony. So this is usually 1 meter wide.
Length. Okay.
Yeah, or the length. Okay, and you can cut it if it doesn't fit in the balcony. But for the height, it needs to be ordered as the same height of the balcony, and we can provide them between 16 centimeters up to 30, 40, 50. What do you want?
So the height can be from 16 up to 40 or something. And this dimension here, the width?
The width, it can be 80 or 120 millimeters.
These are fixed, 2 fixed dimensions, 80 or 120.
Exactly. So of course, the 120, the thermal performance of the 120 is better than the performance of the 80 millimeters. But what you need to know, it doesn't need to be exactly the same thickness as for the insulation. So I mean, if you have a building with, let's say, 10 centimeters insulation, you can take the products with 80 millimeters. It's not a problem at all.
Okay. Another guy is asking, what about the overlap length of the steel bars or of the fiber bars? Can they be customized too?
Yeah, so it can be customized. So here you have the standard products.
He means this length now here.
Yeah. And we have this kind of product. So just give me a second. This kind of product with a anchor head on one side. It's just when you don't have any room for the bars. So typically when you have a step between the balcony and the slab.
Okay. Will you show us a photo?
Yeah. Can you see it? It's on my screen.
Not yet. I don't know. I think I see the type K still.
No. I don't know why it takes so much time. So okay, so just let's just wait a couple of seconds and
okay. Another guy is asking, okay, understood about the construction, but what about our calculation? Because we have to put also your data in our static software. How we do it that? You give us the data?
Yes. So for let's just imagine that you have the forces on the balcony, the forces on the balcony will go through the isochord, and they will.
No. Benoit, don't explain me the how could I the static.
Okay.
It's again a question of procedure. They say, okay, we have made the static calculation here in Greece, and we give you our data about the balcony. This is a conventional balcony. We have made the calculation as a conventional balcony for the static. And you say now, okay, we can do it with a thermal break. You have to give us data back to put it in our static software. Do you do that?
I'm not sure I understand what you mean with data for your software. Maybe Jonathan?
Yeah, so I would say it's mostly the same as a conventional. So we are going to take the forces that a conventional balcony will impose, and we are going to transfer those onto the interior slab.
Okay.
So it's mostly the same. And if there are questions about the stiffness of the product, then we can give further details. If there's questions about the vibration of the balcony or the deflection of the balcony, then we can answer questions about the stiffness of the product. Because of course, the stiffness of our product is going to be much less than if it was a just a concrete connection, because our product only has small concrete pieces and steel bars.
Okay.
But as far as the transfer of the forces, that's the same. That can be considered the same as a conventional balcony. So there's no special, what we take from the project engineer or from the architect are the forces of the balcony, and we say, okay, we are going to transmit these forces from the balcony to the inside, slab or beam or whatever it is.
Okay. Allow me to say to Βασίλη, μπορεί να ρωτήσει και αγγλικά αν θες εδώ στο chat και να το μεταφράσω εγώ. Who was there? Benoit, you were on?
Yeah, I just wanted to say something on top of that. You know, when we telling to the engineer, you will need 5 pieces of this one, 3 pieces of this one, and so on. Of course, we give the resistance of each element. So the project engineer will get the resistance of each element we recommend, and of course the layout drawing, so that he knows where each element should go.
Okay.
Another thing that we provide as a standard is we make some recommendations on some rebar, so that we have a good connection between our product and the interior slab and the balcony as well. So the question we had previously about the overlapping length, that's also going to be provided by the products that we supply, because when we have stronger, heavier products, they have longer bars to allow for a better lap splice or overlap length between the slab rebar and the product rebar.
Okay. I know that there are some guys which are very good in static here between us. I don't know if they want to explain more, because I'm not the static specialist, but let me ask some of them in Greek maybe. Γιώργο, Λιάκος, είσαι εδώ. Θες να πεις τίποτα, να καταλάβει, έχεις καμιά απορία ή όχι?
Έλα, Στέφανε.
Ναι.
Έχω τα μωρά γύρω μου και είναι λίγο δύσκολο. Κάτσε λίγο. Δώσ' μου λίγα λεπτά.
He has the babies and the family close to him, he said, but okay. He will speak to us. Any other guy who wants to make a question or to make a comment or something?
I can show something which explains better how we can calculate the balcony.
Okay.
So I'm just showing something on my screens. It will obviously take a couple of seconds.
No, we see it.
Okay, great. So you can see the first step is to design the balcony. So this is something we do by ourselves, and then to gather the forces on the isochord. So this is the diagrams you can see on the middle, and with those values we can design the isochord. We will tell you need this reference, and then the engineer can apply those forces on the edge on the slab of the slab. And then he can design the slab. So I'm not sure if it answered the question. Well, I'm showing that because you told me that some guys are expert in statics, but I can understand it can be a bit disturbing for people who are not very comfortable with structural calculation. Hello?
Stefano, we don't hear you.
Sorry, my mistake.
Oh, okay.
Vasilis is asking, with this system, if we put between the main building and the balcony, after that it isn't necessary to insulate the whole balcony. Exactly that, Vasilis. Yes, this was the main idea. Γιώργο.
Έλα, Στεφανέ.
Για πες.
Λοιπόν, θα τα πω ελληνικά τώρα.
Okay, he will speak Greek and I will translate. Sorry.
No problem.
Ρωτούσες για τα στατικά, τι κάνουμε εδώ στην Ελλάδα.
Ναι.
Δεν ξέρω τώρα, κάποτε υπήρχε και ένα πρόγραμμα της SCHOECK, δεν ξέρω αν το έχουν ακόμα το λογισμικό υπολογισμό.
Το οποίο το δίνανε τι?
Ναι, υπήρχε στο site. Το έχω εγκατεστημένο.
Do you still have a software which can be downloaded from your website where you can do this static calculation? Or it's different now? Because George says he had years ago, he had downloaded some software from the website and he could do a kind of calculation for isocorp.
Yeah, so for the calculating the support reactions of the balcony, so in order to get what you can see on the middle, we have a software for that. In fact, we are renewing the software, and we will have a new one available in maybe a couple of months or so. Anyway, the old one works very well. So our software can calculate that. Of course, the last picture on the right, this is not for our software. Of course, this is I mean, your FEM calculation. But for the first step, yes. What you can see here is not our software. This is a calculation I made by myself with Global, which is a FEM software, because you can also use regular FEM software to design that. You don't have to use the software of SCHOECK. Of course, it's easier to use the software of SCHOECK because you can directly get the proper reference. But anyway, don't worry, because again, we do this calculation for you. So you are free to do it, of course, but we do it as well.
Γιώργο, για πες, τι είχες προβλήματα, τότε που το είχες ψάξει, τι είχες βρει?
Όχι, απλά αυτό που τέτοιο. Στην ουσία κάνουμε τον υπολογισμό εδώ πέρα, όπως λύνουμε στην Ελλάδα, για να βγάλουμε τα μπαλκόνια και όλα αυτά. Και μετά περνούσαμε τα δεδομένα στο προγραμματάκι αυτό που υπήρχε, και από ό,τι κατάλαβα υπάρχει ακόμα και απλά θα βγει κάποιο καινούριο σε λίγο.
Εγώ ένα πράγμα δεν κατάλαβα που το ρωτήσανε και πριν.
Το πάχος του isocorp και έβγαζε τον τύπο που ο τύπος έδειχνε το τι σίδερα είχε μέσα, τέλος πάντων, και όλα αυτά ανάλογα με τα φορτία και το μήκος του προβόλου και όλα αυτά τα δεδομένα, τέλος πάντων, που θέλαμε εμείς για να ταιριάζει. Δεν σε ακούμε, Στέφανε, κάτι πατάς.
Εσύ αυτά μετά τα ξανάβαλες στο δικό σου?
Όχι.
Τα ξαναβάζεις στα στατικά ή τα στατικά τα αφήνεις?
Όχι. Τα στατικά τα αφήνω όπως είναι.
Οκ. Ωραία.
Γιατί θεωρήσεις ότι αυτό το πρόγραμμα αντικαθιστάει το κομμάτι της σύνδεσης μπαλκονιού με το πόλο κτηρίου?
Οκ. Ωραία.
Από ό,τι είχα δει τότε υπήρχε κάποιο ειδικό τεμάχιο τότε που το είχα ψάξει που είναι για τις σεισμικές φορτίσεις.
George says that he remembered that there was a special product or a special part
XT, κάπως έτσι το έλεγα.
Called the XT or something like that, which was especially for earthquake. For earthquake forces.
Yeah, when you have some horizontal forces, so with horizontal I mean if you imagine the picture on the left, you will have forces from the top to the down, or from down to the top. So I mean, this is what I mean when I mean horizontal forces.
Okay.
And when you have those horizontal forces, we have in fact a small module which can be put between the 1 meter module, and this small module can support the horizontal force. But you know, I mean, if you have I think you guys are like 70 people or so. If you want to organize a workshop specifically for structural questions and so on, I mean, I can do a presentation about how to calculate an isoquorum, and I can go very deep in details, even in the equations, and show how we use the technical manual to get the proper reference and so on. This is something we can do. Some obvious.
Okay, Benoit, we can organize this maybe in autumn. So after the September or something like that. It will be very, very interesting, I believe. Now let's go I don't know if someone else wants to make a question. He can take the floor. Or she. No one. Okay. So let's be, you said before that I remember you said on a slide with a parapet that insulating the parapet was maybe more expensive than using your product. And this is a little bit amazing for us because we have also a lot of parapets. So is it so that so can you give us some numbers now about costs? What does it cost per running meter, or on the parapet or in the balcony, in order to have, let's say, a first view of what we are discussing? Because I believe at the end everybody will ask this question.
Okay, I will just answer because Benoit, he's sitting with me here and he does not hear you, but I heard your question.
Okay.
So yeah, the cost, it's difficult to say because we don't know exactly what the situation is. If we have higher forces, so if it's a taller parapet, then we need to have the connections spaced closer together.
Mm-hmm.
If it's a very short parapet, then maybe we can have a connection every meter, and then in between the connections we can just have insulation piece. And then in that case, you can actually save insulation going all the way around the top and the side and the back of the parapet. So yeah, realistically it could be equal. If you have a very cheap insulation, then maybe it's actually cheaper, the materials, just putting this insulation on. But when you also consider the quality of the design and the fact that it's maintenance free if you have a thermal break, if you have an insulation and then you have connections through the insulation, that could lead to leaks. You could have maintenance issues in the future. So yeah, those are all things to consider.
Mm-hmm.
If yeah, I mean, it's difficult to give a guide, but we could say for a balcony connection, if you just have a connection on a slab, not a beam, it could be about between 100 or 200 euros per meter.
Per running meter of the
per
balcony.
linear meter, yeah. Depending again on what is the cantilever length of that balcony, right? How strong does the product have to be? Yeah. And then the parapet connection
it's definitely lower than the numbers that we have heard here in Greece during the last years. I can tell you now, Isabel, because we have the discussion. So the numbers were much higher. So I don't know, George, Yakos, do you remember numbers prices that you have become from here, from the distributor?
Δεν το θυμάμαι τώρα, δεν το θυμάμαι καθόλου. Ήταν αρκετά μεγάλο ποσό βέβαια για να επιλεγεί τότε σαν λύση.
3-4 χιλιάρικα ήθελε στο μπαλκόνι.
Δεν το θυμάμαι τώρα, Στέφανα. Ίσως ήθελε κοντά στο μέτρο, κοντά στα 300-400 ευρώ.
So yes, the George says that the numbers that we have got, let's say 5 years ago or something, were something like between
Θέλεις να το ψάξω, κάτσε την πόρα,
400 and 500 euros per running meter.
Το ψάχνω και αν το βρω θα
that was the reason that everybody was laughing. Because you can understand that these kind of prices are not interesting.
To be honest, we have already done some projects with such expensive isocorps, but it was like for a swimming pool with 3 meters cantilever and a 50 centimeters slab. So with a lot of reinforcements, you know, the kind of project you do every 3 years or so. But this is definitely not the typical price.
It's not the average multifamily building that I have shown you about an hour ago.
Definitely not.
Because we fight now, you know, we must also build nearly zero energy buildings and passive houses here in Greece, and we are, you have said before, we have now fight with architects because we say, you know, we have to make your balcony slab 30% or 50% thicker because we have to insulate it. So, and if you want an alternative, there is only a thermal break an alternative. So, but until now it was very expensive, very expensive.
Yeah. Anyway, you know, usually what some people do, they get in touch with us very soon in the project. You know, even if they are still designing and they are wondering how they can do that. So, I mean, not 3 months before the construction starts, but really like 6 months before or even 1 year before. And we can advise on how to save on thermal breaks, because, you know, sometimes if you can take some decisions so that the thermal breaks are even cheaper. And on top of that, we can even make an offer at the very beginning of the project, you know, so that there are not any surprise later. This is also something we do quite easily. So again, I can only advise and say get in touch with us as soon as possible. But definitely for a typical residential balcony, it's not that expensive. Definitely not.
So it's very interesting because I hope and I believe that many of the people that are following today the workshop will contact you and have a first prize, and maybe I will also do it because I have also projects. So we have to try it to see how it goes and how it can be in a Greek balcony.
Please feel free to get in touch with us. We will be really more than no, I'm not kidding. I mean, it's our job. So we will be more than happy to provide you some recommendations and an offer. And yeah.
And what we can do is just work on a pilot project, for example, on a test project to help you understand how it works and just to get a first feeling, a first idea of the product. And as you said, maybe it would be good to have a deeper training after the summer to go in deeper into details. And
yes, we can do. We will definitely do it, because you see that even now in the middle of July, where the most of the Greeks are on the beaches, 60 people are here and watching us at 9 o'clock in the evening.
Yeah, that's crazy.
So,
that's crazy.
And we appreciate a lot.
Yeah, definitely.
And we also thank you that you are still also here after work.
We don't have any nice beach to go, and anyway, it's way too cold.
Okay.
But yeah, the idea of Isabel is great. We could do a pilot project. So if you can find a project, even if the building is already completed, it doesn't matter. I mean, we can do an offer like if it was a real project. And anyway, yeah, we can organize a presentation, maybe more the technical stuff, how to design that, the earthquake and everything later in the year, of course.
Okay. And also, let's go also a bit in the steel construction, because steel construction is also something which is growing in Greece sometimes. So there are many people that prefer, even in single family houses, steel construction than concrete. Although I'm not a fan. To be honest, my last attempt was one of the last projects now, and it's very, very difficult to create a passive house with steel construction.
Sure.
It's a nightmare, to be honest. So there we need more pieces. But I believe, if I understand well, there it is easier, or not, the thermal breaks. For not only for balconies, for many things in the steel construction.
I'm sorry, I'm not sure I understand the question.
Benoit, I don't mind answering this one. So
Yeah, okay, sure.
With the steel construction, Benoit showed you some of those pieces, and we put two or four of our thermal break pieces to connect a full beam, for example, steel beam. If you have a very, very heavy beam for a very, very long cantilever, maybe 5 meters or something, then you'll have to add many, many pieces of our thermal break to that beam. And then after a certain point, it stops helping the energy savings.
Exactly.
So yeah, there are challenges with steel for that as well. For a
normally in the steel construction, we have smaller balconies. So
yeah. And so then that's good for us. And we can also, we have products that Benoit showed that connect from a concrete slab to a steel exterior beam. And that's a very efficient product.
Special pieces for corner balconies. Is there a special situation in the corner?
We have a standard product for that.
Okay. You want to show something, or do you have something like a picture or something?
Sure, but it seems that you need to activate the screen sharing for me.
Ah, okay. Sorry.
No problem.
There you are.
Okay. Okay, I'm sorry. Type C. So can you see it?
We see. I don't know what you are showing us. I see something, but there is a menu there. I cannot see what exactly is.
Jonathan, can you see that properly or not?
Jonathan, you are muted.
Yeah, he's muted, but he was saying no, you cannot see it. So I don't know what's happening. I'm really sorry. I have the picture on my screen. Well, in fact, it's basically 2 pieces of straight isocorbs, but the steel bars on one side is a bit higher than the other side, so that it can cross, without any conflict.
Okay.
So it's a standard product anyway. So this is something. I don't know if you remember in the slide, I showed a picture of a site, of a job site, and it was a corner balcony. So, yeah, maybe you do not remember. But
okay, so the website is SCHOECK.com, and they can go to products and see all kind of isocorps here.
Yeah. Can you see my screen, or is it still?
Yes. I can see your screen. Yes.
It's frozen. Okay, so never mind. It's
and you can on the website you can also download the technical information where you have all technical information requested per type of product.
It's time for the computer to go to the beach as well.
What we could do is maybe within the next days we can gather all the questions.
Yes, but there is another question, although it is in Greek again. Βασίλη, θες να μου πεις λίγο ποια φωτογραφία εννοείς? Το σκαρίφημα που ήταν στην τομή, τι ακριβώς?
Ναι. Μ' ακούτε?
Ναι, σας ακούω.
Καλησπέρα. Πριν δείξει το σκαρίφημα με τα ατυχεία, τα παραπέτη, είχε δείξει 2 φωτογραφίες που ήταν πώς συνδεόταν η πλάκα με το μπαλκόνι. Και σαν σκαρίφημα και σαν φωτογραφία. Αυτή, αν μπορεί να την βάλει για 1 λεπτό.
Benoit, can you go back to your presentation?
Yes.
Because there was a section of a balcony.
Yeah, just a second. I'm just trying to.
And it was clear the connection there.
Okay, so a section of the balcony. I guess we are talking about this one. No. Why? Okay, just a second. This one?
Jonathan, I see myself, so I'm not interesting. So
I'm sorry.
it's okay. I don't know if someone else can see that, or can show that, but okay. Okay, let's see
Okay.
it. Maybe, guys, can you give us the? Can we give us to upload also the presentation? Is it possible?
Yes.
Now we see your presentation. This
Okay,
one.
now we see
Βασίλη,
it,
αυτό
yeah.
είναι. Βασίλη, αυτό έλεγες.
Και αυτό και ένα ακόμα μετά από αυτό είχε.
Okay, and the next one maybe. Για πες τώρα τι θες να ρωτήσεις.
Τίποτα, να το έχω σαν αρχείο, να το δω για να το καταλάβω.
Θα την κατεβάσουμε όλη θα την πάρουμε όλη την παρουσίαση. Okay, someone else who wants to comment something or to say something or to ask something for this first workshop?
Again, what I say, what we can do is we can share the presentation, definitely.
Okay.
We can give you a few days to gather all the questions, maybe to you, Stefan.
Okay, sketch. I will. We will also put the recording on our channel in YouTube, and then we will collect questions from the group. And I will also share your emails and contact details and everything, and then you can have. And the next step will be to organize
A second session.
A detailed workshop and detailed session in let's say in September, by end of September or something like that. Okay.
Yeah, sure.
Then I would say thanks a lot.
We will say also thanks a lot, guys. It was very good to have this contact again. I believe the Greek country is a very interesting market for you.
Yes.
And we must proceed because this is a very interesting product which solves a lot of problems here.
Yes. So we go step by step.
So, and if it's cost effective and achievable, why not to use it?
Yeah.
Ευχαριστώ πάρα πολύ. Thank you guys being with us again tonight. We keep in touch. Good vacation. Good vacation for you if you go to vacation.
Okay. Thank you very much for your time, because you've also spent 1 hour and a half, and we appreciate a lot. And yeah, hopefully we can have another meeting in the coming month. So thank you very much and enjoy your evening.
Good night.
Okay.
Okay.
Bye.
Thank you.
Bye
Bye.
bye. Thank you.
Stay safe, guys.
Yeah, you too.
You too. Bye.
Bye.